All right. You'd probably laugh if I told you this will be the third time I am going to attempt to record 5.2 and 5.3. I don't even want to talk about it, but I'm at home in my pajamas, so I can't complain. All right. 5.2. We're talking about polynomials. Polynomials mean many pieces. Okay? Oops, many pieces. Many pieces such as y minus 6y cubed plus 8y to the fifth minus 9y to the fourth plus 12. Many pieces. Now, the first thing we need to learn is that the protocol says we write them in what we call descending order, meaning highest exponent to lowest. So this should be written as 8y to the fifth minus 9y to the fourth minus 6y to the third. There's no y to the second, so then just the y, and then the constant at the very end. Because I want you to consider, this constant actually is 12y to the 0. What did we learn in our last section? Anything to the 0 power is 1. So this 12 times 1 is just 12. But it's like there's an invisible y to the 0 there. Okay? All right. Again, what if I had negative 2 plus m plus 6m squared minus 4m cubed? In descending order, protocol says it should be written in like negative 4m to the third plus 6m squared plus m minus 2, descending order. Okay? Now, another thing they want you to know is to find the degree of a polynomial. So let me write a couple here, and we're going to talk about what is the degree. Okay? The degree deals with looking at the exponent and finding the largest exponent. Whatever the largest exponent is, that's the degree of the polynomial. So let's look at these and determine the degree of the polynomial. Okay? All right. This one, the degree is 2, highest exponent. This one, the degree is 14, highest exponent. This one, there's only one variable, one exponent, so it is what it is, 1. This one doesn't even have a variable. Remember, though, what can we assume? There's a variable to the 0 power. Now, for these two, when you have more than one variable in a piece being a monomial, each piece of a polynomial is called a monomial, you take the two exponents and you add them. So in this case, the degree is 5. If I add these, I get 12. There's a 1 here, so if I add those, I get 5. And there's a 1 both there and there, so if I add those, I get a 2. What's the highest number? 12. All right. Just a few little things that they wanted you to know. Now, what is this whole lesson about? It's about adding and subtracting, or what we call combining, polynomials. And you combine like terms. So, for instance, if I had negative 5y to the third plus 8y to the third minus y to the third, they are all like terms. The variables are exactly the same. So we concentrate on the numbers in front and we combine those. Negative 5 and 8 is 3, and then there's a 1 here. Negative 1, 3 minus 1 is 2. So my answer is I've combined like terms and I get 2y to the third. What if I had 6x plus 5y minus 9x plus 2y? Combine like terms. The x's are the same. Combine, you get negative 3x. The y's are the same. Combine, you get 7y. Answer. Now look carefully at this. What would happen? Are these all like terms? x squared y, xy squared, x squared y, and xy squared. They're not all the same, but this one and this one are. So I get 14x squared y, and this one are. So I get 7xy squared. I can't combine those because they are not like terms, so that's my answer. Okay? Now, they could also give it to you like this. They could say 3a to the 5th plus 9a to the 3rd minus 4a squared plus negative 8a to the 5th plus 8a to the 3rd plus 12. All they did was group them. And they can do that, okay? But what you need to notice is there anything out here that I need to distribute that would change the value? No, 1 isn't going to change the value. Is there anything out here that I need to distribute that would change the value? No, positive 1 wouldn't change the value. So we just combine like terms. 3 and negative 8 gives me negative 5a squared. 9 and 8 give me 17a cubed. There's no other a squared, and there's no other constant. Good. So then, looking at that same idea, what would I do here? Is there anything out here that I need to distribute to change the value? No. But is there anything here that I need to distribute? Yes. And negative 1 will change the value. So this does not change. Negative 1 times negative 5 is positive 5m squared. Negative 1 times 7 is negative 7m. And negative 1 times negative 8 is 8. Now we can combine like terms. Negative 6m and positive 5m give me negative 1m squared. Sorry, that was m squared. Negative 8m, negative 7m, negative 15m. And 5 plus 8 is 13. And there you go. That's 5.2, just combining like terms. Now, 5.3 is a continuation of what we just did, but it brings up the function idea. Do you remember if I had f of x, let's say, is 4x cubed minus x squared plus 5, and I asked you to find f of 3, that means wherever there's an x, I put the 3. Do parentheses first, that's 27, or exponent, minus 9 plus 5. Then multiply 108 minus 9 plus 5, which is 108 minus 9 is 99 plus 5, so you get 104. Now that's just a review. That's just a review. What 5.3 is all about is something that looks like this. F plus g of x, or f minus g of x. Now, this means f of x plus g of x. This means f of x minus g of x. So with that said, let's look at what this means. What if I said the f function, f of x, is x squared minus 3x plus 7. And the g function is negative 3x squared minus 7x plus 7. And I asked you to find f plus g of x and f minus g of x. Now remember, that means f of x plus g of x. Well, do I know what f of x is? It's x squared minus 3x plus 7. Added to, do I know what g of x is? Negative 3x squared minus 7x plus 7. We just did this. Is there anything to distribute that would change the value? No. Is there anything to distribute that would change the value? No. So we can just start combining. X squared and negative 3x squared gives me negative 2x squared. Negative 3x and negative 7x gives me negative 10x. And 7 plus 7 gives me 14. Done. All right. What about this one? And remember, this means f of x minus g of x. All right. What is f of x? X squared minus 3x plus 7 minus g of x, which is negative 3x squared minus 7x plus 7. Is there anything here to distribute that would change it? No. But is there something here to distribute? Yes. So this part doesn't change. Negative 1 times negative 3x squared gives me positive 3x squared. Negative 1 times negative 7x gives me positive 7x. And negative 1 times 7 gives me negative 7. Now I combine like terms. 1x squared and 3x squared is 4x squared. Negative 3x and positive 7x is 4x. And 7 minus 7 is nothing. So there's my answer. So we're still adding, we're just looking at it in a different way. That's all. All right? Now, that was all with x. I asked you f of x plus g of x. What does it look like this? Let's get our function. F of x equals 10x squared minus 2x, and g of x is 2x. I want you to find f plus g of 2 and f minus g of 1. Remember, if they ask you in terms of a number, your answer will be in terms of a number. All this means is f of 2, oops, no parenthesis there, plus g of 2. Well, I don't know what f of 2 is, and I don't know what g of 2 is, but I can find out. F of 2 means wherever there's an x, I put the 2. So I get 10 times 4 minus 2 times 2, which is 40 minus 4, which is 36. So if you think about it, I found what f of 2 is. F of 2 is 36. Now we're going to add it to whatever g of 2 is. All right, we can find g of 2. G of 2, oops, I stated in red, that's fine, is 2 times wherever the x is, I put the 2, so it's 4. And g of 2 is 4. Add them together, my answer is 40. All right, let's try this one. This one right here means f of 1 minus g of 1. I don't know what those are, but I can find them out. F of 1 means wherever there's an x, I put the 1. So I get 10 times 1 minus 2 times 1, which is 10 minus 2, which is 8. So that means f of 1 is 8. Now I'm going to subtract whatever g of 1 is, and I still got to figure that out. All right. G of 1 means wherever there's an x, I put a 1. So what is g of 1? 2. So g of 1 is 2. That means 8 minus 2 is 6. Whoop, muted myself back. If they ask you in terms of x, you give your answer in terms of x. If they ask you in terms of a number, you give your answer in terms of a number. All right. Now, there's one more thing that they want you to know in this section, and these are called composite functions, and they look like this. They don't mean fog and goth, and it's not a closed circle like a multiplication. It's an open circle. This is read f of g of x and g of f of x. Now, I want you to think about it as whenever you see this little open circle, put a parenthesis through it, and then at the end. Put a parenthesis through it, and then at the end. Now, we'll make sense of this in a minute, okay? Knowing that, they are going to give you the f function, and they are going to give you a g function. They are going to ask you for f of g of x, and they're going to ask you for g of f of x. Now, they're asking us in terms of x, so our answers are going to be in terms of x. Now, what did I tell you? Put a parenthesis through here and at the end. Put a parenthesis through here and at the end. Now, let's look at this. This literally is saying that. I just rewrote it. When we talk about parentheses, we always work from the inside out. Do we know what g of x is? We do. So we can replace g of x with x plus 3. So now we're really looking for f of x plus 3. And you know, wherever there's an x, you put whatever's inside here in its place. So we get x plus 3 squared. And that's your answer. I know that's weird and kind of confusing. And I'm going to leave it like this. We're not going to multiply this out because we don't multiply until the next section. So, all right, let's do it again, and let's look at this. Let's rewrite this. This literally will look like that. Do we know what f of x is? Yes, we do. It's x squared. So really, what we're looking for is g of x squared, which means wherever there's an x in the g function, we put the x squared in. So my answer is x squared plus 3. All right, let's do another one so that you can kind of get the idea, okay? This time, I'm going to do f of x equals 4x minus 1, and g of x equals x squared plus 5. I want you to find f of g of x, and then I'm going to mix it up. I want you to find g of f of 1. So now I'm asking for a number. So here I'm asking for an x, my answer will be in terms of x. Here I'm asking it in a number, so my answer will be in terms of a number. All right, let's put our parentheses around and rewrite it. I'm really looking for f of g of x. Do I know what g of x is? I sure do. So I bring that down. I'm really looking for f of x squared plus 5, which means wherever there's an x in the f function, I put x squared plus 5. Now, I can reduce, or not reduce, but simplify this by distributing the 4. So I get 4x squared plus 20 minus 1, which is 4x squared plus 19. And we're done. Starting to see the pattern? One more. This is g of f of 1. G of f of 1. Do I know what f of 1 is? No, but can I figure that out? Sure. F of 1 means wherever there's an x, I put the 1. So I get 4 minus 1, which is 3. F of 1 is 3. So what I'm looking for is g of 3, which means wherever there's an x in the g function, I put the 3. So I get 9 plus 5, which is 14. All right, composite functions can be a little confusing, but I know you can get through them. Give it a try. That was 5.2 and 5.3. I've done it 3 times now. Let's hope this works. Yay, I hope this recording works. All right, y'all have a good day. Bye.